Okay, so let's take a look at this 108, which is where things get fun, because now we're going to make poisoned images, and you can see what the poisoning was. So first we download some data and install the SecML library again, as we've done before. And now we're going to get some samples using only the digits 5 and 9 out of this data set of handwritten digits. All right. And it's going to get a small set of just 100 training set samples and 500 validation and test samples. So there they are. And now we're going to view a few of these so we can see what they look like. All right, so these are 5, the labels above and the images below. So these are 5s and 9s. And as you can see, some of them are sort of bent over and distorted and others aren't, but they're pretty obviously what they are. So now we train a classifier just like before. That will make a binary classifier to tell the 5s from the 9s. And we're using a small data set, so it should run pretty fast. All right, it's 93.6% correct at telling these two apart. Now we're going to perform an evasion attack. We're going to modify the test images so the model will make more errors. And we're going to calculate this is the attack library that is carefully going to calculate modifications that will confuse the model the most. And when it's done, remember the model previously was 93.6% accurate. Now we're going to see the numbers here. Right, the classifier is still 93.6. I think this image is wrong. All right, let's see. Yeah, this is what I wanted to show you. And my image, for some reason, in my instructions is wrong. So I'm going to save this image. Let me just do, there. I'll save it to replace that image later. The point is, here's the attack. So on the reduced test set, which is 25 images, before the attack, it was 100% accurate, but after the attack, it's only 12% accurate at sorting these images. So this is a very powerful poisoning attack, and we can look at the images to see what has happened to them. And that's here. All right. So here you see the original images, and this is the right answer, I think, is in parentheses, and the predicted answer is here. No, it must be the other way. The right answer is the first number, and the one in parentheses is prediction. And here's the poisoning. And you see the poisoning is just add a little bit of faint dots around there, but this is enough to confuse the model and think it was a 5. And here, just a little bit of noise here was enough to make it think it was a 9 when it's actually a 5, and so on. All these images are incorrectly identified, and you can see it just needed a little ghostly stuff here that, like, this wouldn't fool a human. That's still a 5. This is a 9, and this is the trick. And this is the problem I mentioned before, that you can confuse machine learning models with things that wouldn't confuse a human. So if you put like some shiny dots on your face, that will make facial recognition fail, typically, that sort of thing. Small change that wouldn't fool a human will fool the machine learning model. And there's a lot of flags you can find here with different variations, but you get the idea. This little bit of snow added to the image can confuse the model because it's just mathematically combining some of these pixels, and it will get confused. And you can predict from the model which pixels are the most important to the model and change them so they have an unexpectedly large effect on the output. So that's what I wanted to show you. Some evasion attacks leading up to one you can see and easily understand. So let me stop this.